Welcome to qnawire.
So in this problem, we're asked to find the ratio of the gravitational force that the sun applies to the moon divided by the force that the Earth applies on the moon. So for any two objects, objects 1 and 2, the gravitational force between them is just going to be g, the gravitational constant, times the two masses divided by the square of the distance between the two masses. So to find the ratio here, we're just going to apply that equation to both the sun, the moon, and the Earth and the moon. So in both cases, then, we're going to have just g, and then times the mass of the sun times the mass of the moon, divided by the distance between the sun and the moon squared. So that's the force the sun applies on the moon. And then to get the ratio, now we divide this by the force the Earth puts on the moon. So in the denominator now we have g again, mass of the Earth times mass of the moon, and divided by the distance between the Earth and the moon squared. And so now when we're evaluating this, the gravitational constant cancels out. So the ratio doesn't actually depend on the gravitational constant at all. And then also the mass of the moon cancels out as well. So the only things that matters here for this ratio are the mass of the sun, the mass of the Earth, and the distance between the sun and the moon and the Earth and the moon. So this then reduces to just the mass of the sun divided by the mass of the Earth, and then multiplied by the distance between the Earth and the moon, and the distance between the sun and the moon. And then both of those are squared. So now we look up the values for those in the appendix. For the sun, we have 1.99 times 10 to the 30th kilograms. And for the mass of the Earth, we have 5.98 times 10 to the 24th kilograms. And then for the distances, we have the distance between the Earth and the moon is 3.84 times 10 to the 8th meters. And between the sun and the moon, we have 1.5 times 10 to the 11th meters. So we have that the sun is heavier than the Earth, and that the Earth is closer to the moon than the sun is to the moon. So both of those check out. And so kind of because the sun's heavier and the Earth's closer, these forces kind of end up canceling out more or less. And so when we evaluate this, we get only 2.18. So that tells us that the sun has a gravitational force on the moon 2.18 times as strong as the Earth on the moon. So bigger, but not by a whole lot. So we're asked then which is more accurate, is the Earth orbiting the sun or is the Earth orbiting the moon? If we had to pick, we'd say it's orbiting the sun, but really probably most accurate is to say that it's a combination of the two. We can't really accurately describe the motion as just orbiting the sun or just orbiting the Earth.